Welcome to the final lecture of this course. We're going to do something directly practical. I'll walk you through the 10 most frequently asked big data architecture questions in senior data engineering and data architect interviews, and I'll give you model answers for each one. These are not theoretical questions. Every one of these has appeared in real interviews at companies like Google, Amazon, Meta, Spotify, and major financial institutions. I'll also give you the STAR format: situation, technique, answer, red flag to avoid, for each question. By the end of this lecture, you will be prepared for the architecture portion of any senior data interview. Interview question 1, Q1. Explain the difference between Lambda and Kappa architecture. When would you use each? Model answer: Lambda, 2 parallel processing paths, batch plus stream, for use cases requiring both historical accuracy and real-time speed. Kappa, single streaming path, used when event log is replayable and you can tolerate replay time for corrections. Key trade-off: Lambda has code duplication, Kappa has reprocessing cost. Red flag to avoid: saying Kappa is always better than Lambda. They solve different problems. Pro tip: always mention the trade-off, not just the description. Interviewers want to know you think in trade-offs. Delivery guidance: answer in 60 to 90 seconds maximum. Start with the core distinction. Give one concrete example, then mention the trade-off. Never give a list of features without a trade-off. That's a textbook answer, not an architectural answer. Interview question 2, Q2. How would you design a real-time fraud detection system? Model answer: Kafka ingestion right pointing arrow, Flink stream processing right pointing arrow feature store, Redis. For less than 10 milliseconds, feature retrieval right pointing arrow ML model inference, right pointing arrow decision API. Parallel batch path through Spark for model retraining. Key: feature store prevents training serving skew and meets latency SLA. Red flag to avoid: not mentioning the feature store. This is what separates good answers from great ones. Pro tip: quote, specific latency numbers, 80 milliseconds less than 5 milliseconds Redis. Specificity signals real experience delivery guidance, answer in 60 to 90 seconds maximum. Start with the core distinction, give one concrete example, then mention the trade-off. Never give a list of features without a trade-off. That's a textbook answer, not an architectural answer. Interview question 3, Q3. What is a data lakehouse, and when would you use it instead of separate lake plus warehouse? Model answer: lakehouse adds a transaction log, Delta Lake/Iceberg, on top of cloud object storage, enabling ACID transactions, time travel, and query optimization without the cost of a separate warehouse. Use when you need both ML flexibility and analytical reliability, when budget doesn't support running both, or when you want a single source of truth. Red flag to avoid: confusing the lakehouse with just a data lake with better organization. Pro tip: mention Delta Lake and Iceberg by name. They're the specific implementations that matter. Delivery guidance: answer in 60 to 90 seconds maximum. Start with the core distinction. Give one concrete example, then mention the trade-off. Never give a list of features without a trade-off. That's a textbook answer, not an architectural answer. Interview question 4, Q4. How do you handle exactly once processing in a streaming pipeline? Model answer: 3 mechanisms. 1. Kafka transactional producers for exactly once writes to Kafka. 2. Flink checkpointing with two-phase commit for exactly once between Kafka source and downstream syncs. 3. Idempotent sync writes using unique event IDs to deduplicate at the destination. Red flag to avoid: saying, we use Kafka so it's exactly once. Kafka at least once by default. Exactly once requires explicit configuration. Pro tip: demonstrate you understand that exactly once is expensive and not always necessary. At least once, with idempotent syncs, is often preferable. Delivery guidance: answer in 60 to 90 seconds maximum. Start with the core distinction. Give one concrete example, then mention the trade-off. Never give a list of features without a trade-off. That's a textbook answer, not an architectural answer. Interview question 5, Q5. How would you scale a Kafka cluster from 500 gigabytes per day to 5 terabytes per day? Model answer: add brokers horizontally, right pointing arrow increase partition count for affected topics, right pointing arrow rebalance partitions using Kafka partition reassignment tool. Key considerations: partition count must be greater than or equal to consumer parallelism. Avoid reducing partitions, not supported. Monitor consumer lag during rebalancing to ensure no processing delay. Red flag to avoid: not mentioning consumer lag monitoring during rebalancing. This is a production concern. Pro tip: rule of thumb: start with partitions equals 10 times expected consumer threads to allow future scaling without topology changes. Delivery guidance: answer in 60 to 90 seconds maximum. Start with the core distinction. Give one concrete example, then mention the trade-off. Never give a list of features without a trade-off. That's a textbook answer, not an architectural answer. Interview question 6, Q6. What is data lineage and why does it matter in a big data system? Model answer. Data lineage tracks the complete journey of data from source to consumption. Which systems produced it, what transformations were applied, which downstream systems use it. Matters for debugging. Where did this wrong value come from? Regulatory compliance. GDPR right to erasure requires knowing all copies. Impact analysis. What breaks if I change this upstream table? Tools. Apache Atlas. Databricks Unity Catalog. Open lineage. Red flag to avoid. Only mentioning debugging. Compliance and impact analysis are equally important, and often the primary business driver. Pro tip. Mention open lineage as the emerging open standard. It demonstrates awareness of current ecosystem. Remember, the best interview answers demonstrate trade-off thinking, specific technology knowledge, and awareness of organizational context. Never give a purely theoretical answer, always grounded in a real or realistic scenario. Interview question 7. Q7. How do you prevent a big data pipeline from becoming a data swamp? Model answer. 4 practices. 1. Data catalog with business descriptions and ownership. Apache Atlas, AWS Glue catalog. 2. Schema registry to enforce structure at ingestion time. Confluent schema registry. 3. Data quality checks at each pipeline stage. Great expectations DBT tests. 4. Clear data lifecycle policies. Define when data moves from raw to processed to archived to deleted. Red flag to avoid. Only mentioning documentation. Governance is operational, not just documentary. Pro tip. Frame data quality as a pipeline stage, not a separate team responsibility. Quality checks belong in your Airflow DAG. Remember, the best interview answers demonstrate trade-off thinking, specific technology knowledge, and awareness of organizational context. Never give a purely theoretical answer, always grounded in a real or realistic scenario. Interview question 8. Q8. How would you design a big data system for a team of 3 engineers versus a team of 30? Model answer. 3 engineers. Managed services only. Kinesis, MWAA, EMR, Kappa architecture to maintain one codebase. Simple storage. S3 plus Redshift. Minimize operational surface area. 30 engineers. Can justify self-managed Kafka cluster for cost. Lambda architecture viable. Data mesh principles applicable as teams split into domains. Key insight. Operational complexity budget scales with team size. Red flag to avoid. Recommending the same architecture regardless of team size. This signals lack of real-world experience. Pro tip. The phrase operational complexity budget impresses interviewers. It shows you think about total cost of ownership, not just infrastructure cost. Remember, the best interview answers demonstrate trade-off thinking, specific technology knowledge, and awareness of organizational context. Never give a purely theoretical answer, always grounded in a real or realistic scenario. Interview question 9. Q9. What's the difference between a hot path, warm path, and cold path in big data? Model answer. Hot path. Milliseconds to seconds latency. Streaming processing. High cost per byte. Used for real-time dashboards, alerts, ML inference. Warm path. Minutes to hours. Micro-batch or near real-time. Moderate cost. Used for operational reporting updated every 15 minutes. Cold path. Hours to days. Batch processing. Lowest cost per byte. Used for historical analysis, model training, compliance archives. Red flag to avoid. Only describing 2 tiers, real-time versus batch. The 3-tier model shows architectural maturity. Pro tip. Map each path to a specific technology. Hot equals Flink plus Redis. Warm equals Spark streaming plus Delta. Cold equals Spark plus S3 plus Glacier. Remember, the best interview answers demonstrate trade-off thinking, specific technology knowledge, and awareness of organizational context. Never give a purely theoretical answer, always grounded in a real or realistic scenario. Interview question 10. Q10. Describe a big data architecture failure you've seen or heard of, and what you'd do differently. Model answer. Classic example. The data lake turned data swamp failure. No governance, no catalog, no schema enforcement at ingestion. Within 18 months, nobody trusted the data. Query times degraded due to small file proliferation, and business teams built shadow Excel workbooks. Fix. Schema registry at ingestion. Delta Lake for ACID plus compaction. Data catalog from day 1. Data quality checks as Airflow tasks. Red flag to avoid. Saying, I've never seen a failure. This signals inexperience or lack of reflection. Pro tip. This question tests intellectual honesty and learning orientation. The interviewers want to see that you learn from failure, not that you've never failed. Remember, the best interview answers demonstrate trade-off thinking, specific technology knowledge, and awareness of organizational context. Never give a purely theoretical answer, always grounded in a real or realistic scenario. Congratulations! You have reached the end of the Big Data Architecture Masterclass. Let me leave you with the most important career advice from this lecture. The difference between a junior and senior architectural answer is trade-off thinking. Any candidate can describe what Kafka does, Senior candidates explain when Kafka is not the right choice and why. Specificity signals experience. Saying we use Redis for sub-5 milliseconds feature retrieval with a TTL of 24 hours is more impressive than we cache the features. Use specific numbers and configurations. Architectural decisions have organizational context. The right architecture for a 3-person startup is different from the right architecture for a 300-person enterprise. Always ask about team size and budget before proposing a solution. Governance is not someone else's problem. Data catalogs, schema registries, data quality checks. These belong in your architecture from day one. The "we'll add governance later" approach always results in a data swamp. And finally, intellectual honesty is a strength, not a weakness. Every experienced architect has built systems that failed in some way. Being able to articulate what went wrong and what you'd do differently demonstrates the reflection and learning orientation that distinguishes great engineers. Thank you for completing this course. You now have the framework, the case studies, the modern topics, and the interview preparation to excel as a big data architect. Go build great systems.